Which statement is correct for this reaction? So this is the reaction, and we're given that delta H is negative 26.6 kilojoules. Negative delta H indicates that this reaction is exothermic, meaning energy is released. We're also given that the 2 ion is produced, releasing negative 26.6 kilojoules. As the question wants to know how much energy is released per mole of ion, we need to divide the delta H by 2. So for this question, we're asked to find the expression for the mass. We're given the Q, the heat, mR, molecular weight, and delta H, the enthalpy change. We know that delta H is equal to heat over number of mole, and we also know that mole is equal to gram divided by molecular mass. By combining these two equations, we get this new equation of heat multiplied by molecular weight divided by the mass is equal to delta H. By rearranging this equation, we can find the expression for the mass. After that, we just have to substitute the values in. For delta H, we can ignore the negative sign as it just means that it's exothermic. As this is a combustion reaction, it is an exothermic, meaning delta H is negative. Moving on to delta S, change in entropy. Entropy is an HO content, but in a nutshell, it represents the extent of messiness. How I approach these questions is I count up the coefficient on reactant and product side. So for this question, we have 7 versus 12. As 12 is a greater number than 7, we can say that product has a higher entropy. Therefore, delta S, high value minus the lower value, will always give us the positive. And we know that when delta H is negative and delta S is positive, the reaction will always be spontaneous. Which statement about this reaction is correct? So we're given that delta H for the dissolution of ammonium nitrate is positive 26 kilojoules per mole. As delta H is positive, we now know that this reaction is endothermic. Dissolution of ammonium nitrate means that ammonium nitrate is dissolved in a liquid. As this reaction is endothermic, energy is absorbed, heat is required on the reactant side. And as the temperature increases, there's more available heat, producing more dissolved ammonium sulfate, resulting in increase in solubility. Which change of state is exothermic? So we're given 4 reactions. The first one, you're going from carbon dioxide solid to gas. So as you can see from the drawing, solids have a low kinetic energy. It has low movement, while gas, they have relatively high kinetic energy as they're freely moving around. Hence, as you're going from low energy state to higher energy state, it requires energy. Therefore, this reaction is endothermic. Moving on to the second equation. You're going from water in a liquid state to gas. So as you can see from the drawing, liquid state has a relatively lower kinetic energy, the moving energy, than the gas. And as you're going from low to high energy state, this one also requires energy. Third equation, you're going from ammonium gas state to liquid state. And as you can see from the drawing, gas has a higher kinetic energy and liquid has a lower kinetic energy. As you're going from high to low energy state, you have to release energy, meaning this reaction is exothermic. Finally, the last reaction, you're going from iron solid state to the liquid state. So solid have relatively low kinetic energy and liquid has a higher kinetic energy. And hence, as you're going from low to high energy state, you require energy, and therefore this reaction is endothermic. What is the expression for the enthalpy of neutralization? So let's just quickly write down the reaction between sodium hydroxide and hydrochloric acid, producing salt and water. We know that enthalpy of neutralization can be defined as heat release in neutralization reaction per every mole. And we know that heat, Q, is equal to mass times specific heat capacity and delta T, change in temperature. Hence, delta H can be rewritten as MC delta T divided by N. Now, for the mass, we know that mass of the product is all the combination of the reactant. We have 25 centimeter cube of sodium hydroxide and 25 centimeter cube for hydrochloric acid as well. And as we know that mass is equal to density times volume, total volume, and we're given in question that density is 1, hence the product mass is 50 times 1, 50 gram. And we're also given that specific heat capacity is 4.18 and delta T is expressed as delta T. Now finally, the mole. To find mole, we need to know how to do stoichiometry and how to use concentration formula. We know that concentration is mole over volume. We can rearrange this to mole is equal to concentration times volume, which is 0.1 times 25. And as the mole for sodium hydroxide is 0.25 and stoichiometry ratio is 1:1 to water, hence the N for this question is 0.25. So now we just have to substitute all these values into the expression, and we have to also acknowledge that this is a neutralization reaction, meaning this is exothermic and delta H has to be negative. What is the enthalpy change for the dissolution of ammonium chloride in water? So as the per question, we're given that 5.35 grams of ammonium chloride is used, producing 25 grams of solution with increase in 14K temperature. To find delta H, change in enthalpy, it's heat divided by per mole, which can be re-expressed as MC delta T over N. Mass is 25 grams and heat capacity is given as 4.18 joules per gram per Kelvin. But as the question wants the delta H as kilojoules, we need to divide by 1000. Delta T is 14, and to find number of mole, we have to use stoichiometry. For this reaction, the ratio is 1:1, and as mole is gram divided by molecular weight, which is given as 5.35 divided by 53.5, which equals to 0.1 mole. So the delta H, the enthalpy change for this reaction, we can express this by putting all these values in. Just remember that for heat capacity, as it is given as joules, you have to divide by 1000. Which processes are exothermic? So we're given 3 reactions. First one is between ethanoic acid mixed with sodium hydroxide. So this one is acid and base reaction, producing salt and water. So this is a neutralization reaction, and we know that neutralization reactions are all exothermic. Moving on to second one, we're mixing carbon with oxide gas, producing carbon monoxide. as we're forming bonds, we know that forming bonds or making bonds is always exothermic. Moving on to the third equation, which is carbon mixed with oxide gas producing carbon dioxide. Like the previous equation, this one is also forming bonds, hence this one is also exothermic. Which combination is correct for the standard enthalpy change of neutralization? So we have to know that neutralization is an example of exothermic process, hence delta H is negative. Which statement is correct for the substance? So to approach this question, you need to understand what is heat capacity. It is defined as the amount of heat required for a substance to increase its temperature. So for this question, cobalt has the lowest heat capacity, meaning that if the same amount of heat is given, cobalt will experience the highest temperature change. Which equation represents the standard enthalpy of the formation of liquid methanol? So methanol is expressed as CH3OH. So we need carbon, hydrogen, and oxygen to make methanol. And we have to know that hydrogen and oxygens are diatomic, meaning they exist as a pair. And in normal state, they exist as a gas form. While for carbon, it exists as solid. After that, you just have to balance the equation out, and there we go. Which equation represents the standard enthalpy of the formation of tetrachloromethane? So tetrachloromethane is CCl4. So we need carbon and chlorine on reactant side. Chlorine is a diatomic, meaning they exist as a pair, and we just write its normal state and balance it out. Thanks for watching. Please drop a like if you have enjoyed, and don't forget to subscribe for new content. The next content will be about calorimetry. Wish you all the best for your study, and I really hope to see you again. Bye.